Today's objective is to distinguish between high and low-level programming instructions. So we've talked about machine language before, the ones and zeros. It says here that the instructions we give the computer can come in a variety of ways, that is, languages. But ultimately, they all boil down to ones and zeros. These ones and zeros are encoded to do specific things. The lower language, known also as machine code, bears a strong resemblance to so-called low-level programming languages, a sparse primitive set of commands to directly control the physical electronic operations of a computing machine. The think, write, share here is what could the word primitive mean in this context? If you go back here and look, it says low-level programming languages are a sparse, primitive set of commands to directly control the operations of a computer. Other programming languages are built on top of the low-level languages to provide more abstraction and functionality that combines low-level operations into commonly used procedures. The most commonly known low-level language is called assembly language. Think, write, share. Why would it be helpful to code in assembly if you will be required to type so much more? My analogy example would be assembly is like a set of instructions you'd give a person making a cake, in which every inch of movement is detailed in the instructions. So here's a look at the machine code. This term is used to describe any binary instruction which a computer's CPU will read and execute. For example, there's all the ones and zeros in a row. Each instruction performs a very specific task, such as loading a value into a register or adding two binary numbers together. Remember, computers are just very simple machines that can do simple things like add. Assembly code is the easy-to-read interpretation of machine code. All right? There is 1-to-1 matching. One line of assembly equals one line of machine code. So let's take a quick look at coding in assembly. Down here we have LDA number 23. What this does is loads the number 23 into something called the accumulator. Then add number 42 adds the number 42 to the contents of the accumulator. So therefore we now have 65. And then STO34 save, as in store, the accumulator result to the memory address 34. Notice there is not a pound sign or a hashtag in front of 34 because this is a memory address. So to continue my assembly example and how it could relate to building house, low versus high level programming, think of assembly as you'll have to tell the computer to first cut the board, move the board, nail the board, and then go to cut board 100 times loop. So you'd have to cut 100 boards, and those boards would be used to build the house. Now, Perl is an example of a higher level language, and look how beautiful this is. You can just say install walls, install plumbing, install electrical, move in. I apologize that this is so hard to read, but I just really wanted to comment on here. This is assembly versus machine code. So you have machine code bytes done in hexadecimal right here, and you can count them, right? There's 1 byte, 2 byte, 3 byte, 4 byte, so on. And then here's the assembly code. So it says move 1, and then here's the hexadecimal, FF001122. So it's just this backwards, right? And then here's the name of a register right there. So this must be the instruction, move. And then to add this register to the other. So, sorry it's blurry, but it's a really good example of what I'm trying to say in terms of machine code versus assembly code. You can go down here and see the instruction stream, which is very fascinating. To look at just the stream of binary that's flowing through the machine for this particular program. So here's more of an instruction stream. Ultimately, you can see what a computer is doing at a very low level. It looks something like this. To the right-hand side here, we just have the ASCII equivalent of what's going on over here. Even though this program may not be looking at a text file at all, here is just another way to look at this instruction stream. And if you're a hacker or maybe a reverse engineer, you would spend time in data analyzers like this. And the dots simply mean the machine does not know what that would have been in ASCII because the number is just not an ASCII number. Computers on the low level can basically only do three things: calculate, compare, and move data. A computer processor is capable of counting stuff, adding two numbers together, subtracting a number from another, division and multiplication, and it's able to count time. Time in this case is made a figure because as the processor sees it, time is merely a question of counting how many blips it gets from the crystal that oscillates the clock frequency. Think, Write, Share, what three things can a computer do? So to a computer, everything is numbers. Press a key on the keyboard sends a number to the computer and expects the computer to do something with it. Move the mouse a bit and a series of numbers are sent to the computer that tells it how the mouse is moving about. Think, Write, Share, what type of numbers do you think would come from the mouse? My example to help you with the Think, Write, Share is that the keyboard probably gives an ASCII number, unless Shift is being held down, then an extra number telling the computer to look at another part of the ASCII table. So if I hold Shift, that's going to be the part of ASCII where those number letters are capitals. For example, 65 is A, capital A. Attach a monitor. It gives the computer a series of numbers that tell the computer how large the screen is, and as a result, a remarkable amount of numbers are sent back to the monitor that tells it should draw what it should draw on the screen. Okay, so that's it for the lesson. Go ahead and choose an IB question to answer to reflect on your learning today. And the DOL is here. Two programmers walk into a job. Their task is to take a list of names and alphabetically sort them. I want you to tell me which programmer used a high-level language and why. So one programmer told the computer, sort the list alphabetically, and the built-in functions of the language she chose converts this to machine code. The other programmer told the computer, take the first name and compare it to the second. If the first letter is lower, then put name A first. If they are the same, then take the second letter, etc. So which programmer used a higher level language, the first one here or the second one? And why?